Hi folks, welcome back here. So today's episode we'll be talking more towards the Montreal Protocol. But before that, let's do a little bit of recap on the last segment on the Antarctic ozone hole here. Right, so we talk about in the Antarctic phase, in the ozone hole, they create a reservoir of the chlorine. What happens is when you have a strong amount of ultraviolet rays here, that acts as a catalyst to decompose these CFCs or related substances into the chlorine radicals that could do propagation reactions again in the radical mechanisms to deplete the ozone into the oxygen molecules here. And because you have the radicals that have unpacked electrons, they have a high tendency to do a recombination reactions in the termination step to form a neutral compound. So you can see here that in the chlorine radical that reacts with the VOCs or certain organic compounds here to form the hydrogen chloride. That's acidic and causes a bit of acid rain in that part of the world, and a transient methyl radical, and this will continue to react with the species, for instance O3, and forms O2 here. There's a separate mechanism here that we discussed earlier on, that you have this chlorine oxide radical reaction with another radical, the nitrogen dioxide, to form this stable species, and then you do a cleavage here and you form another compound. So one might ask, if there isn't any UV light, would that occur? The answer is, if there's no UV light there, of course it would not occur because there would not be any homolytic fissions taking place in the process. Okay. Now, what happens when you have these clouds here, this droplet, that becomes a site of nucleation for this reaction to take place. So that becomes in a way like a catalytic platform for all the reagents together, and react very quickly, is concentrated. So I would associate this with a little bit more like a heterogeneous catalyst, because all these are in gaseous phase, but when you have your clouds here, that's more like a liquid phase. When you have two different phases here that allows for reactions, it is similar to a heterogeneous catalysis, the composition of the ozone. Okay, so you see how this process happened. Now let's move on to the Montreal Protocol that we have heard so much here. So this Montreal Protocol is about the substances that deplete the ozone layer. Well, it is this international treaty, right, that was designed to protect the sacrosanct ozone that protects the human lives, right? So it was signed on August 26, 1987, and it was pursued after there was this meeting in 1985 in the Vienna Conventions for the protection of the ozone layer, which at the meeting they set up the framework about international cooperation to address the ozone depletion. Okay, so once it was signed in 1987, it took about 2 years, right, to enter into force here for the respective states to execute it, right? And since then, it had undergone 9 revisions in a year after, 1990, 1991, 1992, 1993, 95, 97, 98, 99, and latest in 2060 in Kigali, Rwanda. So you might ask, how come there's so many revisions after every year here? Every year? Because when you have new data and we find a certain approach here doesn't work here, you just have to change. You just don't set goals for 3 years from now and just stick to it if it's not realistic and unachievable. So as a result for this international agreement here, right, the ozone hole in Antarctica did return to the 1980 level. Okay, we'll expect it to return to that level in the 2050 to 2070, which I hope I'll still be alive here. I think I will. And this Montreal Protocol, right, is a prediction. This we call it a success, but again, success is defined in people's eyes, right? It could be attributed to this effective curve, right? To share the burden and also a solution proposal, because we find that the world, we share this climate. Okay, some countries might produce more chemicals that deplete the ozone, but we share this world, so it's about making this known, making this aware, and everybody coming together to collaborate to make sure that no certain countries is causing harm to others. So this help to mitigate the regional conflicts of interest, right? You have water interest, we have air interest, pollutions, and this is about ozone interest. And if you recall, there was another protocol called the Kyoto Protocol. It works a bit differently, okay? So I would like to just say that, in this Montreal Protocol, there was a global regulations, right? There was a scientific consensus established, and the public opinion matters too. So they were convinced about this possible imminent risk about the depletion of ozone layer of this ozone hole, right? So therefore, these Vienna Conventions that happened in 1985 and the Montreal Protocol that was signed was ratified by 196 nations, right? And in the EU, European Union, making this the first universally ratified treaties in the history of the United Nations, right? And because of its widespread adoptions, implementations, outreach, this Montreal Protocol has been held as a holy grail example of exceptional international cooperation. Many people cooperate, and the deceased former UN Secretary General, Mr. Kofi Annan, describing as perhaps is one of the most successful international agreement to date. So if there's one takeaway from here, the objective of the Montreal Protocol is really about the protection of the ozone layer through the control of the global productions and consumptions of the ODS. Okay, expressed as equivalent of the effective stratospheric chlorine values, and in the next slide we'll show you. So we do a comparison between if there's no protocol that was signed, right, when there's Montreal Protocol that's being signed here, how it can decimate the amount of stratospheric chlorine that could deplete the ozone in a faster rate here. Okay, so we are glad you also signed, and then we see how the progress is in the next slide. So I will continue later. Cheers.